Hey guys, so recently I've been pretty interested in some racing games and I wondered if I could build an AI that could, I don't know, race an F1 track or a circuit. And the first thing I thought of is to use something called NEAT, which is Neural Evolution of Augmenting Topologies, which I already used for my Snake AI. So it works essentially like natural evolution, but for neural networks. The best neural networks of a generation can be carried on to the next generation and mutate some of the weights and biases, our connections. To measure how successful a neural network is in our environment, we're gonna give them a fitness value. For example, if the car goes off the track, we'll go deduct the fitness value, and if it reaches a checkpoint, then we'll give it a reward by increasing the fitness value. Initially, I wanted it to be as accurate as possible with real-life physics like the car steering and acceleration, and the F1 track has to be up to scale with the car and stuff like that, but a lot of technical issues came along the way, so I decided to just improvise it instead. So as you can see, I made my F1 car, a Pygame rectangle object, but the only way you can rotate stuff in Pygame is to make an image, which means I would have to paste a texture onto it, and that would mean a lot more work. And when I decided to try to load a texture, like a car texture, then some errors came along, which I don't know how to solve it yet because only one forum has talked about it. So I just used a solid color. Alright, so for the track, I used the 2025 Las Vegas circuit. It was pretty hard to drive through, so I just made the lanes a bit bigger. I know it looks bad, but I think this is the best I can do to make it easier for the AI to learn, and as long as it doesn't require anything really sophisticated techniques that I haven't programmed, then I think it's gonna be fine. So the green lines you see here throughout the circuit are the checkpoints, and we're gonna reward the AI if it goes to the next one and punish the AI slightly if it goes back to the previous one. And the rays you see coming from the car, the yellow rays are like ray tracing to see the distance between the car and the track. So I got one directly in front of it, and then 45 on both sides, 90 degrees on both sides, and one directly behind it. And then the purple ray, really thin, is from the car to the next checkpoint. So the relative position between those two. And those are going to be our inputs for the AI. Also, the blue rectangle is to see the collision rect for the car. Not extremely accurate, but it's gonna work for now. Now it's time to train the model. I used a library called Python Neat to implement the Neat algorithm, and it takes in a configuration file. We also had to set up functions for training the neural networks and evaluating the fitness of each genome. After that, we're gonna store the best genome into a pickle file, and then we have to write another function to get the pickle file and then run it after we're done training. So what I realized from running these simulations like a bunch of times is that each time the results are very different. For example, once I ran it for over 100 generations and the best fitness was only negative 300, and once I ran like 50 generations and the best fitness was like 30,000, which is really good. And then sometimes I ran for 500 generations and it plateaued for a while, and then it got to fitness of around 1000, which is actually worse than the 50 generations one. You can see the AI is pretty good compared to my attempt at the track, and with around 100 generations and ending at 40,000 to 80,000 fitness, I think this is pretty good. Much better than my snake AI. Well, this project was pretty fun and educational. Thanks for watching. I'll see you guys in the next video.